Okay, today we're going to talk about adding and subtracting rational expressions. So we've already talked a little bit about multiplying and dividing them, but today we're going to talk about adding and subtracting. Think about what we already know about adding and subtracting fractions. One thing we know is that we have to have a common denominator. And so to get a common denominator here, I look at the 3 and 9, and I look for a number that they go into. Now they both go into 27, they both go into 18, but the smallest number that they both go into is just 9. So I'm going to multiply both of these by 3. Notice that when I multiply both of these by 3, really what I'm multiplying by is just the fraction 1. And when you multiply by 1, nothing changes. And so that's why I'm going to write an equivalent fraction here. 6/9 is equivalent to 2/3. And so I'm going to take 6/9 plus 7/9. They have a common denominator. That denominator stays. 6 plus 7 is 13. So the nice thing is, as I come over here, I'm going to do the exact same idea there. I'm looking at my denominators. I'm looking to see, is there something I can multiply one or both of these by so that I can get the same thing in both denominators. And as I look at this, what I start to see is this one has a 3, this one has a 6. Well, I can multiply the 3 by 2, and if I multiply the 3 by 2, I could get the 6. This one has an x cubed, though. This one just has an x. Well, if I multiply this by x squared, that would give me x cubed over here. And so what I'm able to do is I'm able to multiply the left fraction here by just 2, and the right fraction I'm able to multiply that by x squared. Make sure you do it to both top and bottom there so that you're really just multiplying by 1. Write your equivalent fraction, 10 over 6x cubed. This one, 7x squared over 6x cubed. Just like over here, when you have once you have the common denominator, you can add across, and the denominator stays the same. So my denominator stays the same, that's 6x cubed. When I add the top, I take 10 plus 7x squared. That should be a squared there. 10 plus 7x squared. And so I got to go through and rewrite that on there. 10 plus 7x squared. Now, if I could combine those, then I combine them. But remember, you can only combine x squared with other x squareds. And so here I cannot combine these two things. Now I look, is there a number I can pull out of these? There isn't a number that I can pull out of those. And so on this particular problem, I'm done. Remember, we cannot simplify the x squared over x cubed here because the x squared is part of this addition problem. The only way you can simplify is if the whole numerator was being multiplied by x squared. Then I could simplify x squared and x cubed. But here, just the 7 is being multiplied by x squared, not everything. And so that is all the farther I can go with that problem. That problem is done. Remember to look to simplify here each time. Let's look at another problem now involving subtraction there. This one's a little more difficult. As I look at the 5x minus 2 and the 5x plus 1, I start looking for ways I can change it. One temptation here is to add 3. But be careful when you add to the fraction, even if you add the same thing. So let's just say I have 1/2 and I try to add, we'll say 4. Well, 2 plus 4 is 6. Well, I know that a half, if I'm looking at what half of 6 is, I know that that should be 3 here. But 1 plus 4 equals 5. So the problem is 1/2, if I add 4 to both sides, does not stay equivalent. 5/6 is not the same as 1/2. This is not a valid way of trying to keep it equivalent. So I can't try to keep these the same by adding 4 to both the numerator and the denominator. So what I do want to do, though, is I can think about what I did with regular fractions. Think about what you did with fractions when they had like 17 and 9 as the denominators. So two numbers that were kind of difficult to find matches for. Our method that we used if that happened was to just multiply them together. We'll do the same thing with these rational expressions. We'll just go ahead and multiply this times 5x minus 2, both numerator and denominator, and we'll multiply this times the 5x plus 1. And so as I look at that, I now go to simplify this. My denominator is set. My denominator is the 5x plus 1 times 5x minus 2. That's my denominator. In the numerator, I have the 4x times 5x and the 4x times the 1. So I have 20x squared plus 4x. Here, I got to be real careful. This is minus 2x times 5x minus 2. So remember, minus goes with negative, so I'm thinking that as plus negative here. And so I'm really thinking of a negative 2x that I'm bringing into both of those. Negative 2x times 5x is negative 10x squared. And negative 2x times negative 2, negative times negative is positive. And then I have 4x there. Now comes that step of simplifying. I'm still leaving my 5x plus 1 and my 5x minus 2. I want to keep those factored out for a variety of reasons. But the top part here I can simplify. So the numerator, I have 20x squared here minus 10x squared. That's going to be 10x squared. And then I have 4x's here plus 4 more x's. That's going to be 8x. Again, I'm constantly trying to simplify here, and so I want to leave these factored out so that I have that product still. Here, I want to continue factoring as much as I can, and so I'm looking at 10x squared and 8x, and I'm looking to see if they both have anything in common. As I look at those, they do. 2 goes into both 10 and 8, and they both have at least 1x. So I can pull out that 2x, and when I pull out that 2x, I'm left with 5x plus 4. Because 10 divided by 2 is 5. I take away an x. I have an x here still. 8 divided by 2 is 4. I take away an x. I no longer have an x. I still have that over 5x plus 1 and 5x minus 2. Now, if these matched up, I could simplify them and cancel them out to be 1. But here, these do not match up. There's no 2x here in front that I could cancel that out with, or even an x in front that I could cancel out with. So there's actually nothing I can do here, and so that will be my answer. Want to leave it in factored form. It allows us to see easily where it is undefined at, and it allows us to make sure that we cannot simplify any farther. And let's end this with a little bit of a joke, and the joke is, how did one telephone propose to the other telephone? It gave it a ring. Have a great night, guys. Eat some bacon. We'll talk to you later.